So, welcome to the course on cloud computing. Today we will be discussing on cloud fog computing paradigm, why it is important. So, already you have gone through the basics of and some of the aspects of cloud and fog computing. We will be in coming couple of lectures, we will be discussing little more in details that how this overall performance issue, latency etc. are make sense while we have this type of paradigm, why this is important and why we need this sort of a thing. So, more to say it is a cloud fog edge, sensors and other systems will come into play. Let us see that during the lectures that we will look into the things. So, primarily we will have a overview and also we will look into a case study, primarily look into a health cloud fog framework. Some of the things that we will share, that some of the work we did in our lab out here for realization of this cloud fog paradigm for a health domain. So, it may be in a lab setup, but I believe that will give you a good understanding that why this sort of a framework matters, and also we will look into some of the performance related issues this particular paradigm have a lot of promises to give. So, these are some of the key words which will be there. So, to start with, let us have some quick recap. So, when we talk about cloud computing, it comes as something as a service, rather if we say anything as a service which comes into play. So, three predominant services or three predominant model what we look into is one that software as a service, right? These are the different service model, and or platform as a service, and infrastructure as a service. So, if we look into the overall thing, so infrastructure as a service gives me that basic infrastructure to do this computing thing. When you have a platform as a service, so we have something, or rather as a software as a service, I do not care about the infrastructure and things like that. I directly want to have that realization of the software into the thing, working of my tools and softwares over this computing platform. And in between we have this platform as a service which provides me a platform, maybe for development, for execution, some of the things to work on the things. Other than thing, we have lot of other things, like we are used to like sort of a storage as a service, or something like database as a service. So, what we are saying that somewhere ubiquitously the services are available, and I can call that service and pay per use, right, as or pay as you go type of model. We pay as far as we use, and we know that some of the major characteristics are, one is on demand self service, that means with minimal management interventions things should be there, resource pooling, broad network access, rapid elasticity and measured services, right. Though it is what we say it came from a distributed computing, gradually distributed computing platform, but if you look at in some aspects that it is some sort of a what we say as far as the cloud is concerned, when we work with it. Say suppose I hire a cloud from say either Amazon or Google, or maybe we have a in IIT Kharagpur we have developed a cloud or a cloud infrastructure with ourselves with using open source, that is Meghamala, whatever we look at as when I am working is some sort of a centralized stuff. Not only that, it is somewhere there. So, I need to send my data out there and get the result out of it, if it is something which is for computing, right. However, in some cases this network delay may be much more, right. With all these different type of advantages what we are looking at, instead of having owned infrastructure, I can have a ubiquitous infrastructure which help me in increased mobility, least botheration of my maintaining the infrastructure. I just hire a infrastructure like computing as a service. So, with additionally there are issues of where we have these latencies and other things into play. In some scenarios, especially mission critical scenarios and like that, what we feel what is seen that this may be sometimes more challenging of having this sort of a data traversal over network and delay, etc. So, another thing which came up in after this cloud computing and what we studied is the fog. So, as the name suggests, cloud is up in the sky and then fog is something little down or more near to the surface or more near to us, right. So, it is a model in which data processing and applications are concentrated in devices at the network edge rather than the existing almost entirely on the cloud. So, it is something where in the cloud. So, we want to have some realization of this say in the processing term or analysis terms or the data somewhere in between, right. So, in other sense what we see that instead of traveling direct to the cloud, if I can have in between this type of services, it may make sense for better performance, right. So, the term fog was originally coined by Cisco Systems as a new model to ease wireless data transfer to distributed devices in the IoT paradigm, right. So, as we have huge number of sensors and sensors actuators which are collecting data and being the data being analyzed and may be actuated for some other purposes. So, what is seen that there is a tremendous data flow is in the network, right, with the increasing number of sensing devices. And so, Cisco with their huge infrastructural this network infrastructure, what is seen that whether it can be used that unused or used resources in the network can be used in the things, especially look at the nodes like routers, etc., which may be having good amount of computing resources, but for this transfer may not be there. So, I can do it in at a much lower level. So, what happens? So, if we look at a scenario like as we have discussed, say I am sitting in this room, we have say 3-4 such studios in this particular floor. So, every studio may be maintaining a temperature with some 10 to 20 sensors. So, overall we may, if there are 4 studios and there are 40 sensors which are sending data to the cloud analyzing those, taking a call whether the temperature need to be increased, etc. And type of things, right. So, while sending the data, it is aggregating into a intermediate node or in an intermediate switch or a router where it being transmitted at the next things, or what we say it is being aggregated at the gateway. So, what if see the this particular application, if the temperature control is the application, it could have been good that if a preliminary things, suppose everything is okay, no need of transferring this data of the things, like. So, if I say that I need to maintain the temperature between 20 to 22 degree centigrade and it is between and plus minus 2 degree. So, if instead 18 to 24, I mean if it is within, if my local node of this 10 sensors of this room is think that it is within the range, it will not transmit, it will say that things are okay, or it may transmit that it is within range type of things, right. So, what way this will help? It will help that I reduce this load into a much lesser thing. So, what we are trying to do? We are trying to do the computing at a much lower level because some resources are available, right. It can be network things, later on we can say it can be my mobile device, it can be some other things which are say excess resources are available, whether I can use for computing at that purpose. So, anyway we need to transmit to the cloud because the cloud may be doing a global analytics where it sees all the 4 rooms, say for this typical synthetic case, right. Otherwise, if I am doing on a local things, I only see the data of this particular room. So, as Cisco is having a huge infrastructure of their network, so that may be one of their motivation of using that for computing purpose, and it is much lower than the actual cloud which is on the little far away. So, it is what we termed as a fog computing. So, vision of fog computing is to enable applications on say millions or billions of connected device to run directly on the network edge. So, instead of pushing to the other end of the network, whether I can execute at the edge of the network itself, in thus reducing the overall traffic load of the rest of the network, which saves network delays or of course energy, and quote unquote overall costing on the things, right. So, just this is a thing what you have already seen. I am not going detail into the thing. So, there are some so called differences between this cloud and fog computing paradigm, like latency, typically cloud in case of a high, where fog is lower than that, or delay jitter, say things like say geographically it is something, some sort of a centralized cloud where it is particularly distributed, and so on and so forth. So, there are different pros cons both the things, but what we, and if you see this typically this comparison table, it may appear that why cloud, why not only fog type of things, but we do understand that the fog is not a replacement of the cloud, right. So, it is more of a something what we say a complementary or a supportive technology to the things, which helps in better utilization of the infrastructure. So, cloud need to take a maybe a global call of what is going on overall, means overall infrastructure wise, and cloud can provision different type of service things, which fog may not be able to do that. Fog has low resource mostly in comparison to the cloud, and much nearer to the things, and it does not have a global vicinity, whereas it may provide better security or type of things if you are putting those type of resources on the things. It supports some sort of a mobility, and there are the latency is low, and so on and so forth. So, it makes sense, say if I have some sort of a infrastructure which goes hand in hand, right, what we say a paradigm where we have cloud, fog, and rather we keep this edge also, where actually my sensors etc. are capturing the data, transmitting the fog to the things. There are little what we say little thin line between that, where this edge ends and fog, some of the references you will find that interchangeably fog and edge computing are being interchangeably used. Nevertheless, what we want to see it like that. So, I have a sensing devices, right, which can be like IoTs and different category of things who are sensing data, right, and that is transmitting to the this fog nodes, right. So, where we refer here the edge is those type of sensors, right. Nevertheless, those sensing devices may have some sort of a intelligence, or may have some resources by doing some processing there, like typically reducing some trivial noises, so that the more clean data being transmitted, and so on and so forth. So, what is the thing that bringing intelligence down the cloud close to the ground. So, we have this cloud up in the so called up in the quote unquote sky, and then bringing this intelligence down the towards the surface, right. So, that some of the decision can be taken as a at a much lower level. The challenges are there, that as these are independent things, so they do not have a global view. So, as such the cloud can still take a call of that the data, or what we say this processed data which is being transmitted. But in doing this intermediate layer, what we achieve, that reduce the overall traffic which are being pumped to the cloud, right. We will later on see there is another concept or another technology or approach, what we say dew computing will come later on, right. So, this like cellular base station, network routers, Wi-Fi gateways will be capable of running applications, right. So, if there are resources available, so if it can be cellular base station or our say Wi-Fi routers which are installed everywhere, even these network routers which are highly resourceful and maybe they have excess resources which can be utilized for application purposes, right. I can have dedicated type of things which can do also as a intermediate node or the fog nodes, right. So, end devices like sensors are able to perform basic data processing, right. So, sensors will data processing in the sense data capturing and maybe some sort of a basic filtering like some sort of basic operation and transmit or transmit the raw data to the things, right. So, process close to the device lowers the response time, enable real time application. So, once the response time is lowered, which helps us in achieving real time applications, right, or realization of real time processing of the things. So, what we try to do in doing so that it is multi-layer. There are definitely lot of challenges come into play, right, that how overall management of this data flow will be there, right, how much we gain in doing so, right. And then if I have like if you are transmitting everything to the cloud, so you know that how to handle things, right, you have that particular way to handle. Now, if you have intermediate lot of devices in between which are acting as your intermediate layer for computing, like for computing, then we have challenges like that how we can basically interoperate, right. The data being processed by different, say if my fog nodes are not homogeneous, if my fog nodes are like this, that some fog nodes are say network routers or Wi-Fi routers and some fog nodes are maybe something say mobile device or something else, then how do you handle this type of interoperability and type of things. There are issues of what is the timing relationship will be there, right, some fog nodes sending some data at some rate, some nodes etcetera. So, these are challenges, there are several challenges, or in other sense we need to look into that overall what is the overall performance, whether we gain or not, for all cases whether this will be good or in which cases we need to deploy this type of scenarios, right. So, there are things which need to be looked into. So, if we look at as a cloud fog, we keep the edge type of paradigm. So, what we see the same if you see the same thing in a different form. So, at the ground level we have different sensory devices, right, primarily they are sensing it. If we look at the medical, then it may be sensing different type of things like typical what we say body area networks, right. So, your things like say body pulse rate, heart rate, body temperature, pressure, and it may have lot of other things which can be sensed, right. So, those data are being transmitted to intermediate fog nodes. So, that may take some call like initial pre-processing of the data, that can be one way it is looking at the set, and there can be other type of things also, like if it finds that the basic analysis that a immediate alert is needed to be sent to the patient, like you need to see a doctor or something like that, that can also it can generate, right. So, it is not a one way communication, it is a both way communication between fog and the edge, what we see out here also, right. So, there are both way communications are there. So, so the fog nodes in turn accept this data, do necessary processing at its end, whatever is meant for, and then this transmit this data to the cloud, which is which may be a processed data, right. So, if it is a health related data, so it may be sending a overall health metric along with the maybe the actual data, or it may be sampling the data in some rate and type of things, right. Like if it is a meteorological data, then it is doing something else. So, based on the logic there, whatever is there embedded in the fog, it works on that those logic and work on it, and that is being transmitted there. So, what we gain here, some of the responses are being done out here itself, right, at the fog level. So, this overall this travel time from going from these sensors to this cloud and coming back and giving the result, that is reduced. So, I have a better response time, right, and it may helps in several real time applications, right. And the fog which is doing a partial computation or maybe transmitting the not the whole data, rather a subset of the data or a processed data to the cloud. So, in other sense, it also reduces from this sector also the volume of data into the to the cloud. So, this also helps in overall achieving better response times, low energy cost, and bringing down the overall costing of the thing, right. And that it along with that this fog may be getting from some other data, some other sources, etc. Like if it is a data related to say agricultural related things, the fog data may be getting some of the meteorological data nearby. So, it may be getting other resources, right, or that may be data may be in the cloud. So, there are definitely advantage of having these layers in between, which helps in what we say that partial computation at a much at the network edge. The definitely the cost of all those things is that you need to have these fog devices, right, or your devices which are which can work as a fog node while during this overall transmission thing. So, if we look at that cloud issues or the limitations, this one is the major thing is the latency. So, latency is pretty high at times. So, as we discussed in our previous lectures that it is not a it is not meant for high performance computing per se, right. So, high HPC is HPC. So, cloud may not be may not be mistaken as a HPC type of things. It may provide different things like your high performance computing paradigm, but it is per se is not a HPC platform as such, not looked as a HPC platform. So, large volume of data being generated, right, in as if we, here in this case some of the data sets are restricted here, otherwise huge volume of data is generated. There are which has a larger bandwidth requirement, not designed for volume, variety and velocity type of things like 3 V's of a big data type of concept, right, and generating which are being generated by the several IoT devices, right, which again has different interoperability issues, etc. So, as we are just some few minutes back discussing that there may be interoperability challenges when we have different fog devices. There may those challenges may be there when we are transmitting from the IoT. Rather, I can have a fog device which fog devices which have agreed upon protocol of what they need to transmit to the cloud. In other sense, it helps in it may help in achieving interoperability when the data set are coming from different fog sources, right. So, if we look at the IoT or that is which are here in this case edge devices. So, there one of the major challenge is the processing. You do not have that much processing power at the edge. There are challenges of storage, like usually these devices are low on storage, like if you are using say what we say we are used to this pulse oximeter and etc. They are not meant to store things, right. So, they are low on storage, right, and also they have a power requirement. In several cases they require a power requirement, especially when you have something which is on the on mobility, then you have a power requirement. And fog much lesser latency permits uses in real time application, less network congestion, reduce cost execution at the cloud as we discussed, more data location awareness, like that is one part, that if one fog, and if you have distributed, we have a one cloud, we have a distributed the sensing of room temperature across IIT campus, IIT Kharagpur campus. So, the fog device where it is located, it knows that where the coordinate. So, this inherently I can have a spatio-temporal data, space time along with the other attribute data, right. So, it is a better aware of the things, otherwise you have to transmit always the GPS things, that is also okay, but that increases the load of the data, right, and increases the turnaround time. Better handling of colloquial data generated by the sender, that is also a thing. So, we will just look into a case study quickly. So, which help us in understanding that why studying these two things or overall paradigm makes sense. So, here what we see that three sort of a layers, one is the cloud at the top, what we say level 0, that is no as such hard and fast that how many level etc. we are, this is for this particular case study and discussion. Then we have a ISP in between, and then we have the area gateway. So, these are level 0, 1, 2, and then we have maybe some mobile devices which collects the data from different sensors. So, this is at the level 3, right, and then we have the level 4 type of things. So, this fellow or these fellows may act as a fog network, right, which take a call. So, in other sense the fog may not be a single device, it may have different group of things, or in other sense what we say, we may have a fog networks which helps me in achieving this. And the information flow both side, one usually the up in the north direction the data is more going to the cloud, and analyzed data is data load is less, but nevertheless the information flow on the both side. Now, this is what we did in a very synthetic environment in our lab, and this there is a typical some of the configuration, and this some of the configuration we basically used a simulation platform primarily, that Cloud SIM and iFog SIM. Cloud SIM is a from the University of Melbourne, and iFog SIM is a combinedly developed by a team of Kharagpur, IIT Kharagpur and University of Melbourne, and now they are taking care of that tool. So, this is if we have typical infrastructure thing, and if we have these different type of devices here and which have some latency. So, these are some of the things what we try to see, which with some reference material, then we try to see that how overall performance things matter, right. So, and if we look at this particular application, that components and flow. So, this is something EEG signal, this client module it captures, sent to the client module, data filtering module, data processing module, and event handling module, different event handling. So, there can be a confirmatory module that whether this events has occurred or this alert need to be generated, and it goes to the client module, and then it is that goes to the display or what we say informing the user or the patient to the things, right. If this is my overall flow. So, what we have different modules to execute. Now, we have a module to execute, and we have couple of layers where we can say this I can execute in cloud, this I can execute in fog layer and type of things, try to see things. So, we did some experimentation. Again, I with a caution that this is a very synthetic type of things, it should not be generalized that these results will come everywhere, but we try to see that though things varies when we put layers in between. So, this is again that the placement obtained by different application module for fog and cloud architecture, like client module in the mobile, in case of fog based placement in the fog based module, in the cloud based module in the mobile, whereas data filter module in the area gateway, data processing module in the area gateway, and error handling event handling area gateway, and confirmatory module goes to the cloud, because cloud has the global view that whether it confirm that it is a event has occurred or not, like something a medical event, and maybe if we work on a traffic type of thing, something in the traffic event. And this is in the simulation, while we, as I told that we use this iFog SIM simulator. So, these are the different simulation platform we used, and this is the same thing as we see that This is the cloud, ISP, area gateway, mobile devices, and finally, we have these sensors. Now, if we look there at the performance, this network uses, so is very low in case of a fog architecture, as only few like positive cases in the sense which cases need to be transmitted to the cloud is there, right, or candidate cases are there, to cases the conformity module deciding the is accessed, right. So, the typically the fog load is low. In case of cloud based architecture, the usage is high as all module are on the cloud. So, it has go whether it is say data filtering, it will go to the cloud, whether it is event handling, go to the cloud, and definitely conformative is going, but in this case it goes to the things. Again I am just to keep you again I am to mention that we need to this is a very lab type of experimentation with some small number of nodes and etc. So, in different scenario things may be different, but nevertheless the overall story may be same. Now, cost of execution in the cloud, because what we see that when you use your own infrastructure, that is infrastructure why you are using, because that is surplus, right. So, that is practically no extra cost is involved into the things, but when we go to the cloud type of thing, then we have a problem of this costing of the whole thing, right. So, execution cost is much higher when we in this case in the cloud. And even similarly, if we look at the latency also, so in case of a fog it is more or less stable, whereas after some configuration we have used different configuration as I shown you. So, configuration we see that this latency increases in case of a cloud. Similarly, in energy consumption also these different type of patterns come into play when we look at the different category of energy from the DC, that means data center, that means that actually in the cloud, and then mobile energy and edge, and it varies in different aspects. So, also we tried with a prototype tried to see in the lab that how things works with using some of the medical devices, like as you can see some handband etc., where the data being transmitted, and we have used Raspberry Pi as fog devices, which and AWS or also in-house OpenStack for the cloud, but the in-house thing is the network delay is much less because it is within our IIT Kharagpur network. So, the delay you do not perceive, but if you have external guide like AWS and other things like Google Cloud and type of things, you can have things like incidentally Amazon has given IIT Kharagpur some free credits to the students. So, we utilize those. So, we use different data sets and customize to the formula for analysis. Like what we want to do in doing so is that we need to send a alert that when in this case when the patient should go to a doctor or call for support etc. Now, when we say that it is alert, then we have to have some medical domain analysis into the things, which should run some of the things in the fog devices itself, provided that this fog device has the resource to maintain run those applications, and some of the things should run at the cloud end, right. And we have tried different configuration with respect to resource allocation, customizing the different physical devices and so on and so forth. So, this what we in this thing what we tried to looked into in this our first lecture on this couple of series of not series, we will have 3-4 lectures on this. We want to see that whether having this fog device or cloud fog paradigm or cloud fog edge paradigm, what we try to achieve is some sort of a better efficiency or better performance in terms of delivering any applications, right. In this case the experiment in health application, and we could see some of the performance metrics are giving better results with when we have this sort of a combined paradigm. There are few references, and with this let us end our discussion today. We will continue with this discussion in our next lecture. Thank you.